Bismillahir Rahmanir Rahim. Welcome to the new lecture. In the previous lecture, we have started a linear data structure which is called the queue. Queue means first in, first out, or last in, last out, that we have seen in the previous chapter. Normally, the queue is implemented with the help of the linear array, which use the two pointers, front and rear. Rear pointer is used to insert the value and front pointer is used to delete the values from the queue. Then in the simple queue, we have seen one of the disadvantage of wasting of the memory. What was it? Let's suppose if you reserve the 50 memory cells for the queue in the linear array and you just insert the 10 values, then same thing, then the 40 values are still remaining, but as you consumes how many memory? 50 size of the memory. Another disadvantage in the queue that we have seen, that suppose you have the 5 elements and you delete the first 3 elements and the queue size is full, and then we want to insert the new value, then so that's in simple queue we cannot, because the size of the queue reaches to the last position. So the solution for that problem was we have to merge the last cell with the first cell. Last cell with the first cell to make it circular. Then we have seen the circular queue. In simple queue, we have seen how to insert the value into the queue, how to delete the value from the queue. Same as we have seen in the circular queue algorithms. Circular queue, from the last locations, when you reach to the last location, then you go back to the first position. It is like a circular fashion. Then we have seen the two algorithms, one for the insertion, one for the deletion. And we use the 2 pointers over there, front and rear. Today, we will study the new types of the queue. This is called DQ. DQ means double-ended queue. In simple queue, elements are deleted at one end and inserted at the other end. But in DQ, linear data structure, in which the elements can be added or removed from the both sides, but not in the middle. DQ is the contraction of the name double-ended queue. What does this mean? It means you can insert the element from the either of the side, and you can also delete the element from the DQ from either of the side. Mean you can use the two sides. Simple queue, you can use only one side. Circular queue, you can use only one side for the insertion. But double-ended queue, double means double side. We can use it both for the insertion and deletion. It has two forms: input restricted DQ, output restricted DQ. Input restricted DQ mean insertion from the one end, deletion from the both side. Mean you need to insert the value from one side and delete the value from this side also and from this side. So for deletion, I'm using the two sides, and for the insertion, I'm using the one side. Output restricted DQ, insertion from both of the side and deletion from only one side. Here, insertion can be done this side also, insertion can be done this side also, but deletion from one side. This is called output restricted DQ. There are many ways to representing the DQ in the memory. First one method is by maintaining the circular array with 2 pointer left and right we will use here. Previously it was rear and front, but here we will use the left and right pointer. The same concept, but only the name has been changed. For example, this is a circular queue. Left point, the location number 2, location number 1 is here, location number 2. Left will be used to delete the value. Okay, right, if we write right pointer, location number 4, because it reaches to the last location. Okay, one thing is the queue is circular. I will use the circular queue for the DQ. So after the last cell, which location come? It will go back again to the first location. So for example, here left is equal to 4. Our first value delete kata, second value, third value, fourth. Injara sida. The peshazi rear pointer, right side, also insert the two values 1 and 2. So right point location number 2 and left point the location number 4. Yes. We have circular array DQ with the left and right pointers to the two ends of the DQ. Look at here, try to understand the concept of the insertion and deletion. Insertion, if the element added at the left, then the left is decreased by 1. Please look at here. If the element is added to the left, for example, this is the array, I have the array. So if I insert it from this side, if I'm going to insert, the first value will goes here, second value will comes here, third value will come here, 1, 2, 3, 4. If I'm going to insert the value from this side, so the first value will come to the last location. This is called location number 4. Then if I need to insert the new value, then I have to decrease it by 1. So the left will be decreased by 1. If I'm going to insert the third value, the left will be decreased by 1. It is just an example. Please don't look at these values. These are the not these are the example of the previous. I'm talking about the example of this one, this particular slide. So if the element added at the left, then the left will be decreased by 1. What does this mean? Left here, I insert the first value here. This is location number 4. Then I decrease it by 1. No, this is location number 3. This, and then I decreased by 1, location number 2. So here the value of left here is equal to what? The left here is equal to 2. So it means whenever I'm going to insert the value, the left will be decreased by 1 from the left side. So same is here, we will apply on the right side. If the element added at the right side, then the right will be increased by 1. What does this mean? This is my right side. So if I need to insert the value, so first value will come here. For example, here GGG. I insert the first value, location number 1. Then I need to increment it. I need to increment it by 1. So first right point the location number 1 in the memory. No, it points the location number 2. Then I will increment it by 1. It moves to the location number 3. Then I will increment by 1. It moves to location number 4. So same, the process will be continued. So summary is this: when I'm adding the value from the left side, the left will be decreased by 1. When I'm adding the value from the right side, the right will be increased by 1. Okay, deletion. If the element deleted from the left, then the left will be increased by 1. See, if I delete the first value, very simple. If I deleted the first value GGG, so I need to go where? I need to go to the second location because the first value location is now deleted. Then I move toward the left will be increased by 1. I need to delete the second value, then I need to increment it by 1. I need to delete the third value. So when the element is deleted from the left side, the value will be deleted by, the left will be increases by 1. Okay, when the element is deleted from the right side, this side first. So this is location number 4. Our location number 4 value delete me guna, but the decrease by 1. Location number 6 delete me guna, but location number 2 delete me guna. So this is the summary of the using the left and right pointers in the algorithm. Let's go for the algorithm for the DQ insert. This algorithm is used to insert the element from the right side. Right side means rear side in the DQ. Item in the element to be inserted, n is the total number of element in a queue. So first thing, you need to find it out whether my DQ or my queue is full or not, whether I have the memory to store the new value or not. So first you will have to check for the overflow condition. How we will check it? If the front pointer points the first location and rear pointer points the last location, so it means overflow. Here is the example. Look at here. front points the first location, the value has been inserted, then the second value, third, fourth, in total I have a 5 value, and rear points the last location. I don't have further memory. So this situation is called the overflow. Overflow means the memory is full. If we go toward the second scenario, or front is equal to rear plus 1. Front is equal to rear plus 1 mean here already charkhak zada, it comes toward the circular fashion. And first here rear was here, the front deleted the first two value, or here then I come toward here, I inserted the F, I inserted the G. So here front is point location number 3 and rear is point location. It means rear is one less than front, or front is one more than rear. So such a scenario also called the overflow. This, no, I need to insert the value. I need to insert the value. If rear is equal to null or front is equal to null, it means Q is empty. So set front is 1 or rear is equal to 1. Everything is empty. I will store the value at the first position because I'm inserting it from this rear side. It will come toward the first value. So rear will point now the location number 1, and front is also point the location number 1. This is the first scenario. The second scenario, else if rear is equal to, agar rear ta akhir rasida bud or ma jay dashtam ma chimi kunam rear set me kunam, then set rear is equal to the first cell, rear is equal to first cell, and insert your value else if. Then the last one, else rear is equal to this is the normal situation. I've already inserted the 3 value, so I will increment my rear pointer and I will insert the new value at the location number 4. So rear is equal to rear plus 1. So this was the algorithm to insert the value from the right side, Now we will study the algorithm how to insert the value from the left side. The same is here. First, we will go for the overflow. If front is 1 and rear is equal to null, then we don't have enough space, or front is equal to rear plus 1. Front yak zyada as rear, ya rear yak kam as front. So us surat che beshtar shuma dir overflow as. Else set the front pointer. Agar q bikhi khali bud, front is equal to null bud, rear is equal to null bud, to frontum 1 set ko, rearum yak set ko. Amirakam. Agar front awal location rasida chura ki circular as, huma charkhat mizana baat ware last location. So set front is equal to n. Yeah, same as front is equal to front minus 1. Agar the e taraf ma value readily insert me kunam awal value mein location number 5, baad store mein location number 4, baad sayum. So this algorithm is the reverse of the previous one. The first one was used to insert from the right side, and this one is used to inserting from the front side. Same as for the deletion. For the deletion, we will check first underflow. How can I check? If front is null, rear is null, it means I don't have any value. The queue is empty. So first you need to insert the value, then you can able to delete it. So this situation is known as the underflow. Say front is null and rear is equal to null. Otherwise, delete the item. I say surat ma jamdarin. Agar ma yak element dashtam, ma air delete me kunam. No front ali chira point me kuna, null point me kuna, or rearum chira point kuna, null point me kuna. Then front is null and rear is equal to null. Else if agar front ta akhir location rasida bud, air delete me kuna, بعد ازي قدام location में the location awal بعد ازي f delete में kuna, بعد ازي g delete में kuna, and so on. अगर ने normal scenario ये इसके से value बुत awal location है value delete को, दुयम value delete को, and بعد ازي सयम front is equal to front plus 1, front is equal to front plus 1. This is the 3 normal scenario when we are deleting the element. So same as here, when we want to delete it from the right side. From the right side mean here, from this side here, right side. So how I will delete the value? How I will delete my value? Right side. I want to delete the value from the right side. Look at here now. Same as first I will check the underflow. If front is null, rear is equal to null, underflow. It points nothing. So it was empty. Otherwise delete the value. No, I have a 3 scenario for which I can delete my value. Yeah, Q yak element dash front yak element dash because front is equal to rear both. Yak element में dash alichi में कुना मामू yak value delete को front am null set को rear am null set को खलास. else if या अगर rear location number 1 first location dash no first location adara first location से बाद अजी चरखक में जाना toward rear is equal to n. Yes, else yeah, rear is equal to rear minus 1. Our panjam location delete ko, baad charama, baad sayam, doyama, and so on. So this was the algorithm for the DQs. DQs, normally it has the two sides, insertion from the left side or insertion from the right side, or deletion from the left side or deletion from the right side. We have studied in too much detail the algorithms of the particular DQ. Remember guys, these are the advanced topics. Just you need to clarify the concepts on the algorithm. Right now, forget about the implementation because you have studied just only one course of programming, that is Introduction to Programming. When you study the object-oriented programming, Java programming, then you can able to implement these algorithms in the programming language. Right now, clarify the concepts of the algorithm, that how this algorithm works. Priority queues, the third variation of the queue, priority. Priority means assigning the value. That a priority queue is the collection of elements such that element has assigned a priority and such that in order in which the elements are deleted and process come after the following rules. So we will apply some set of rules. According to that rule, we will process the element, we will insert the element, we will delete the element. The element of the higher priorities come after the process before any element of the lower priority. For example, the kishma panj element dara, the panj element har kunam value ke higher priority dara, bura machi mekunam awal process mekunam. Badazu second lowest priority har element ke dara, urama process mekunam. Inis tartibwar nis har element ki kunam priority dara, ziyad ahmiyat dara, amurama awal process mekunam. The elements with the same priority are processed in the order in which they were entered into the queue. An example of the priority queue is the time sharing system in which the programs of the higher priority are processed. So in time sharing system, you can take the example of the network time sharing system. For example, you have the organization. In organization, you have the one printer. So at the same time, there are three requests. One request come from the CEO. Second request came from the manager. The third request came from the accountant. So there are three requests. Who has the highest priority? Simple as the CEO has the highest priority. So first printing of the process of the CEO printing request will be processed first. Then after that, manager process will be requested. Then the third one is the accountant request will be processed. So it depends on the priority number. So same as here, there are many variations of the maintaining the priority in the memory. First, one is called one-way linked list, and second one is called the multiple queues. This list, we will study after this. We have the chapter of the list. It will be clear in too much detail because we have to spend too much time in the list chapter. So one एक तरह सूरत हुई है कि अज़रूरी list implement करें priority queue. एक सूरत है कि अज़रूरी multiple queues. Let's see both of them in very basic form. So one may maintaining a priority queue in the memory is by mean of list. List contain the three part. List contain a node contain the info field, a long node contain the priority number, and a node contain the link number. What does this mean? Look at here. This is the starting. It has a value A whose priority number is 1 and it is linked with the second memory available free memory, whose value is B whose priority number is 2 and it is linked with the third free available memory. It is not implemented with the help of the array. It is implemented with the help of list. The array element after contiguous memory location mein aaya. The list muhim nest. So C is the value of the third node whose priority number is 2 and it is linked with the fourth available free memory whose value is D, priority number is 3 and close, the list is finished. We will spend too much time in the list chapter. It will be clear in the next chapter, inshallah. So how we will traverse it? Started from the first element, started from the algorithm for the deletion process. Sorry, it's the algorithm for the deletion. Okay. How you will delete? Set item is equal to info of start, wherever it's pointed by the starting here. This one is start. Start point the first node. First node. It holds the address of the first node whose value is a, priority number is 1. And delete the first node from the list, delete it and exit it. A very simple algorithm. Priority queue, algorithm adding of the element. So adding, how I will add this here? I will find first the next free available memory. I will store the value. I will store the priority number and I will exit the list. This is called adding the. So array representation of the priority queue. Another way to maintain a priority queue in the memory by using of the separate queue for each level of priority. Look at here, please. I have total how many queues? 5 queues. For queue number 1 contain 1 element, queue number 2 contain 3, queue number 3 contain 0 element, queue number 4 contain 3 element, queue number 5 contain 1 element. Now first this queue will be processed. After that, here if you go for the multiple execution of the queue, queue number 1 contain the 1 element, where front points the location number 2 and rear points the location number 2. Yes, queue number 2 containing the 3 element, where front point the location number 1, this is my location, the first value going to be processed first, and rear point the location number 3, this is the rear. Okay, the third queue which has 0 element, front points null, rear points null, nothing. Okay, here already ek bar charkhat zada. So here the front points the location number 5 dd, اول ای دیلیت میشه، بعد دبل ای، بعد چرخک میزنه طرفی اف اف، چرا که اخر ویلیو کدام انسر شده؟ اف اف. نو ریر پوینتس دی لوکیشن نمبر 1. ها کیو نمبر 5 یک الیمنٹ دار double G. So double G front'm 4 point में कुना, rear'm front point में कुना. This is called the, this is also maintaining the priority queue. A child and honest politician and Santa Claus all sport a $20 bill on the ground. Who's pick it up? Find it out and let me know then. Okay. Thank you so much. If you have any question, you can ask, you can call me, you can email me, or you can join the meeting. You can ask the question. Thank you so much. Allah.